Here's another problem similar to one that appeared on an AP exam. F of x is equal to x plus 2 if x is less than or equal to 3, and it's equal to 4x minus 7 if x is greater than 3. And these are both linear functions, and the function definition changes at x equals 3. And we're asked which of these three statements are true. So let's look at them one at a time. Number 1, the limit as x approaches 3 of f of x exists. Well, let's think about the limit as x approaches 3 from the left. Well, if x is a little bit less than 3, then it's going to be given by this top expression, so that's going to be 3 plus 2, which is 5. And the limit as x approaches 3 from the right of f of x will be given by this expression, so it's going to be 4 times 3 minus 7, which is 12 minus 7, which is 5. So the left side limit and the right side limit both exist and are the same, so this is true. Statement number 1 is true. F of x is continuous at x equals 3. Well, let's think about the value of the function at x equals 3. F of 3 is what? Well, if x equals 3, then it's 3 plus 2, then it's equal to 5. So the limit, which we saw was 5, is equal to the value of the function, so the function is continuous. It exists at x equals 3. The limit exists at x equals 3, and the value of the function equals the value of the limit. And then statement 3, f of x is undefined at x equals 3. No, it's not undefined. This less than or equal to 3 means it's defined, and it's defined by this expression, and we've already seen that it has a value of 5 at 3, so this one is false. So the question, which of the following statements are true? The answer is 1 and 2. Okay, here's one more, and this is a really good problem. The people who write AP exam questions love problems like this because there's a lot that you have to know to solve this. You have to be able to interpret a function just given a few values in a table. You have to understand something about the continuity of a function, and you have to understand something about a function having solutions and what that means. So let's look at the problem. The function f is continuous on the closed interval 0 to 2. So take note, that's important. It's continuous. And we have values for the function as given in the table. So we're only given a few values, and we're asked the equation f of x equals 1/2 must have at least two solutions on this interval 0 to 2 if k is equal to which of these values. Now the way to do this is to draw a picture. Let me scroll down here or scroll up to make some room for a picture. Let's draw this graph. Okay, so here's our function x and our y-axis, and let's plot the points that we know. When x is 0, let me shorten that up and put a 0 there. 0, we'll go ahead and put these in, 0, 1, and 2, and on our y-axis 1 and 2. When x is 0, f of x is 1, so let's plot that point. And when x is 1, f of x is some unknown value along that line, we don't know exactly what. And when x is 2, f of x is 2. Now note we're told the function is continuous, so it has to go from this point to that point in a smooth curve or a continuous curve, so it might do something like this, or it might do something like this, or it might do something like this. We don't know, but we know it's continuous. It exists at every x value in between. We're only given a couple of x values and this mysterious k here. Now we're told the equation f of x equals 1/2 must have at least two solutions. Okay, let's think about what this means. F of x equals 1/2. Remember, the f of x is the y value, the height of the function. So it has to equal 1/2. Let's sketch this in. A y value of 1/2. It must have that value at least 2 times. So that means in going from here to here, it has to dip below that line and go back up. And then you can see it has one point at this x value, and another point here at this x value, where f of x equals a half. It may wiggle around in such a way that it has more than 2, but if it goes below this line, it will have at least 2 solutions. This equation will have at least 2 solutions. That means there will be at least 2 places where it has a y value, a height of 1/2. So that will happen if k, and what is k? K is the value of the function at x equals 1. It's how high up my function is at x equals 1. Okay, so if k is equal to 0, okay, so in other words, the function in that case would look like this. If k equals 0, the function has to go down and then back up. So it would have at least 2 solutions there. If k were equal to 1/2, then it might have 2 solutions, but it might only have one. It might just touch and then go back up. If k were equal to 1/2. If k were equal to 1, then it might not have any solutions. It might do something like that. It could have 2 solutions, but it doesn't have to if k equals 1. The question states it must have at least 2 solutions if k equals what? So 1 doesn't work, and 2 doesn't work for the same reason, and 3 doesn't work for the same reason. If it's at 1, 2, or 3, it doesn't have to go through the line y equals 1/2. But if k is equal to 0, the height of the function at x equals 1 equals 0, the function has to go through the line y equals 1/2 at least 2 times. So the answer is A.